Good.
And an example would be like a bulk is shoved into a toaster. That would be like a conductor of electricity.
Yeah, and it would conduct heat as well. It's not just electricity, it would conduct heat in addition. So what is conduction? So conduction is, I'm going to say direct transfer of heat from one object to another. Okay, so how does this work? So, vibrating atoms of one object collide with those in another, transferring energy. Now remember, we said that heat transfer is from hot to cold. Hot is high temperature, cold is low temperature. High temperature moves faster, low temperature moves slower. So when we're talking about this, we're talking about objects that are having high energy moving fast, hitting the objects that have low energy moving slow, and the energy goes from the high one to the slow one. So the high energy particles hit and lose some of their energy and slow down. The low energy particles get hit and move faster and gain energy. Okay, so that's how it works. This is, by the way, the most efficient form of heat transfer. If you want to heat something up quickly, this is how you do it. You do it this way. This way heats it up faster than anything else. Okay? You all know this because you've all grabbed hot things before, and it feels hot immediately. Okay? Because it transfers heat really well this way. Okay? An example, she gave the example of like sticking a fork in a toaster. Like it would directly heat up the fork from contact with the toaster. A really simple example I like to give a lot is like grabbing a pan out of the oven, like just with your bare hands. So grabbing, is it 2 feet? I don't know. Grabbing a pan out of the oven. Let's be specific, grabbing a hot pan out of the oven. That contact, that grabbing motion, that's going to directly transfer energy out of the pan and into your hand. Okay. There are tons of examples of these, though. Tons and tons and tons. But they have to be in direct physical contact with one thing to another. Okay? So boiling water is not an example of this, except for the water particles that are touching the pot. Okay? But water itself, boiling, is different. We're going to get to that one next. That's convection. Fire. Fire is not this. If you put your hand in the flames, there's no, like, you're not touching a physical thing. Fire is not you can't hold fire in your hands. Okay? So it's not a physical contact between you and that. That's radiation. We'll get to radiation here soon, too. But conduction, it has to be physically touching things. Holding an ice cube and melting it in your hand. Sticking your hand on a hot burner stove. I don't know why you do that, but it happens. Okay? That sort of thing. So that's conduction. All right, good. Margaret, what about A? What's an insulator? Yeah, so they're poor conductors. Nope, there we go. Poor conductors that transfer heat slowly. Or you can think of them poorly, either way. Okay, so the example of this, you have a hot pan in the oven, but it has food on it, and being the high school students you are, you want to eat that food. So how do you do that? You use some sort of like hot pad or towel to grab hot pan. Because, see, that's a poor conductor. So you can hold on to it for longer before it heats up too hot that it burns you. Okay? It's a poor conductor. Now, you have to be careful. Like, people ask me all the time, well, can I use a towel to do that? The answer is maybe. Because towels themselves are insulators. But towels are also frequently wet. And wet towels will transfer the heat better because water transfers heat better. So if you're going to grab something with a towel and it's hot, make sure that the towel is dry. Okay? This is life advice from Mr. B from physics class. Okay? Good things to learn. Good, so that's an insulator. Interestingly enough, things that are good conductors of electricity are usually good conductors of heat. Things that are bad conductors of electricity are also bad conductors of heat. So insulator works both ways for electricity and heat. B, you're at the beach or the pool. The sand feels hot. The towel doesn't, even though they're the same temperature. So you check the temperature of both. They're the exact same temperature. One feels hot, the other one doesn't. Zoe, what do you think? Why?
Because the towel is an insulator where the sand is a conductor, so it transfers less hot to the ground.
Yep. Towel is a good insulator, and sand is more conductive. Okay, even if they're the exact same temperature, they've been sitting out all day, and they're the exact same temperature. Even if they're the same temperature, one, they'll probably have different amounts of heat in them, or different amounts of energy, I should say. But they'll also transfer heat differently. Some will transfer heat better, and some will transfer heat worse. Things that transfer heat better are going to feel hotter because they transfer more heat into you quickly. Things that are not are going to feel not cool, but they won't feel as hot. They'll still feel warm because they're still a higher temperature than you are. But they're not going to feel like burning on you. Okay? And that's also the reason for having towels at the beach, because then you're got an insulator between you and the ground. Same thing if you have like some sort of canopy or shade. That prevents another type of transfer. We'll get to radiation, but that'll also help prevent some of the heat transfer. Okay, any questions on number 1 on conduction? Woohoo!